So first, next we have color of transition metal complexes. Why transition metal complexes have colored? Why the reason behind it? Now, color arises in a substance due to its ability to absorb certain radiations from the visible region of the spectrum. किसी भी substance का color तब आता है उसमें when it absorbs radiation of a particular wavelength. The wavelength should be in the visible region of the spectrum, because only visible region of the spectrum is visible to naked eye or human eye. And reflected light will have radiations corresponding to the wavelength of complementary colors. So the light reflected as a result, and that will have color of the that will have the color of the that will have the wavelength of the complementary color. For example, like in case of copper sulfate, it appears blue because the light absorbed is red light from the visible region of the spectrum, but the reflected light is that of a complementary color, which is blue. That is why copper sulfate, it appears blue. Now what happens in case of transition metal complexes? The energy difference between two sets of orbital is small, and excitation of the electron takes place from lower energy d orbital to higher energy d orbital. For example, from T to G to EG orbital in case of octahedral complexes, and from E to T2 orbital in case of tetrahedral complexes. And generally all the transition metal complexes which have unpaired electrons, since the energy difference is small, they appear to be colored. Now here we will take the example of titanium complex. So this is the complex of titanium, and the configuration of d orbital here is d1. The configuration is d1. So from the electrons, they will get excited from T to G orbital to EG orbital, and in the ground state, obviously this electron that is present in T to G orbital, and it absorbs wavelength in yellow color, in green and yellow color. It absorbs wavelength in green and yellow colors, and the solution of the complex that appears to be purple, which is complementary color of the absorbed radiation, and that color is the complementary, means your the solution that will appear purple because the complementary color which of our green and yellow is purple. Now we have complexes of copper, like anhydrous copper sulfate is white in color, zinc salts are white in color, silver salts are white in color, scandium positive 3 salts are white in color, titanium 4 positive, that is also, they all are colorless, white in color. Reason behind this is, in case of, you can see D10, in case of copper, zinc, the configuration is full. Both means fully filled configurations they have, so no excitation of the electrons that takes place from lower orbital to the higher orbital. Similar is the case in silver, while in case of scandium and titanium, they do not have any unpaired electron, D0 and D0, and because of this, the excitation of the electron from lower energy orbital to higher energy orbital does not take place. So what happens? They absorb, the light is absorbed, yes, but it is not reflected. Only the absorption takes place. That is why they appear colorless. In case of unpaired electron, what happens? The energy is absorbed, and that energy is utilized in moving from lower orbital to higher orbital. And when the electron, it reaches higher up orbital, it reflects radiation which corresponds to a particular wavelength, and that wavelength is of corresponding color in the visible region of the spectrum, और वही corresponding color जो है हमें नजर आता है जब हमें कोई भी complex जो है वो colored नजर आता है. So this is all about the color in transition metal complexes. Thank you.